Ladies and gentlemen, welcome to the Triune Physics aka Physics Bible. And on today's episode, we'll be solving another question on the equilibrium of forces. A weightless bar is pivoted at its center, and weights of 10 Newton and 30 Newton are attached on one side at 4 meters and 2 meters from the pivot. These weights are balanced by a weight of 25 Newton on the other side. So the question is, how far is a 25 Newton weight from the pivot? Which is, it means we are calculating for distance. Solution. Our parameters from that question, you can decide to choose whichever method you can use for better understanding. Let's extract the parameters. We have F1 to be 10 Newton, and then we have F2 to be 30 Newton. Then for F1, the distance becomes X1, which is 4 meters, and then X2 is 2 meters. Is that clear? Then on the other side, another weight is placed, and let's tag that as F3, which is equal to 25 Newton. And then X3 is now missing. That's what we are looking for. So let's interpret this question using a diagram quickly. A weightless bar is pivoted at its center. Let's draw the weightless bar. It's pivoted at its center. So a knife edge will be attached at the CG. Is that clear? A knife edge will be at the center of gravity. That is at its center. Then weights of 10 Newton, F1, and 30 Newton, F2, are attached on one side at 4 meters and 2 meters from the pivot. So the first, you can see from the pivot is 4 meters. The distance there is 4 meters. Then the second weight of 30 Newton will now be 2 meters from the pivot. I hope you are getting this. So quickly, let's introduce our weights, 10 Newton and 30 Newton respectively, on one side of the weightless bar. These weights are balanced by a weight of 25 Newton on the other side. So let's assume and pick a random position towards our right hand side. Let's attach our 25 Newton weight. Okay, then they say how far is the 25 Newton weight from the pivot. So we are looking for distance X3 from the pivot. So let's solve quickly now. Recall the principle of moment. It states that the sum of the clockwise moments about a point is equal to the sum of the anti-clockwise moments about the same point, which is about the pivot. Please take note of that. So we're going to apply that principle so that we have a clockwise moment, okay, and your center of attraction or attention should be where the masses are hinged. The other part is irrelevant to you. In other words, where the 10 Newton weight is hinged and 25 Newton weight is also hinged is your area of concentration. So recall our clockwise moment and anti-clockwise moment about the pivot. So if we apply the principle of moment, it will now give us what? Summation ACW is equal to summation CW. All together? Yes. So that for ACW, you see that two forces are hinged. Hence, we are going to sum them together. F1, X1 plus F2, X2 will now equal F3, X3. We are summing them because they are at the same position, or they are both towards the anti-clockwise moment. So that by substitution, now we will now have F1 to be what? 10 Newton into 4 plus 30 into 2 is equal to 25 into X. Let's assume x3 is x, is that clear? So that 40 plus 60 will equal 25x. 100 is equal to 25x, divide through by 25, is that clear? So that 100 divided by 25 is equal to 25x over 25. 25 cancel 25, and 100 divided by 25 is equal to x, so that x is equal to 4 meters. That is it. Thank you for joining us. I hope you learned something today. Connect to our social media handles at Physics Bible, the Triune Physics, for latest update. Thanks for joining us. Stay equipped, stay liquid.